Sterilization and disinfection. What is sterilization? It is defined as the process where all the living microorganisms, including bacterial spores, are killed. Sterilization can be achieved by physical, chemical, biological, and physiochemical means. Disinfection. It is the killing or removing of harmful or pathogenic microorganisms. Disinfection can be achieved by physical or chemical methods. The chemicals used in disinfection are called disinfectants. Then we have decontamination. Decontamination is the process of removal of contaminating pathogenic microorganisms from the articles by a process of sterilization or disinfection. Then we have asepsis. Asepsis is the employment of techniques to achieve micro-free environment, such as usage of gloves, usage of air filters and UV rays, etc. Antiseptic, a product that destroys or inhibits the growth of microorganisms in or on living tissues. Aseptic, it is characterized by the absence of pathogenic microbes. Antibiotics are the substances produced by one microbe that inhibits or kills another microbe. We have different methods in laboratory for sterilization purposes, that is physical method, chemical method and biological method. Here you can see physical method and chemical method. Under physical method of sterilization, we have through heat, radiation and filtration. Under heat we have dry heat and moist heat. Under dry heat we have different methods again: incineration, flaming, dry oven, etc. Under moist heat we have pressurized steam, that is autoclave, water heating, boiling water, pasteurization, etc. Under radiation we have ionizing radiations and non-ionizing radiations. X-rays and gamma rays are ionizing radiations, whereas UV light or UV rays comes under non-ionizing radiation. Under filtration we have different filters: asbestos filters or SIDS filters, we say, membrane filters, sintered glass filters. Under chemical method, it is divided into gas and liquid. Formaldehyde and ethylene oxide are the gas we use for sterilization, and other chemical agents are alcohol, halogens, phenols, and aldehydes. So let us move on to physical methods of sterilization. Heat is a mostly used method of sterilization. It is a highly effective and most reliable process. There are two major methods of using heat in sterilization, which are dry heat and moist heat. The principle behind both of these methods is similar. Dry heat induces the denaturation of protein, oxidative damage, and toxic effect due to the high level of electrolytes. The dry heat can also damage the DNA of the microorganisms. The microorganism got killed then. Moist heat kills the microorganisms by denaturation and coagulation of proteins. Here you can see the picture of a autoclave used in laboratory for sterilization purpose. Autoclave comes under moist heat method. Here we use temperature above 100 degrees centigrade. Autoclave is a cylindrical vessel having double walls around all parts except the upper side. It is built to withstand the steam pressure of at least 30 lb per square inch. What is the principle used here. To increase the temperature of steam or gas in a closed system, that increases its temperature, the water molecules become more aggregated, that increases their penetration considerably. The water boils at 100 degrees centigrade depending upon the vapor pressure of the atmosphere. The temperature will be increased if the vapor pressure is increased. The temperature will be increased if the vapor pressure is increased. The autoclave is usually operated at 15 lb per square inch steam pressure for 30 minutes, which as seen from the above, that is 121.5 degrees Celsius. This temperature for a period of 30 minutes is sufficient to kill all the spores and vegetative cells of microorganisms. What are the precautions that must be taken while using autoclave? The level of water should be checked before operating. The air should be completely evacuated from the autoclave, and the steam must have access to the materials to be sterilized. For example, if a material such as cotton, wool, or glass beads is to be sterilized in a glass bottle closed with rubber stopper, the sterilization would not be complete as steam cannot pass through the rubber stopper. What is the procedure? Sufficient amount of water is placed inside the autoclave. The material is placed inside the autoclave for sterilization. The cotton plug should be covered with a piece of butter paper so that the plug doesn't get wet. The lid of autoclave should be tightened with the help of screws. Then switch on the plug. The steam outlet is kept open till we feel that the air from inside the autoclave has been evacuated, and then close the steam outlet. It is similar to that of your pressure cooker. The pressure is allowed to remain at 15 lb per square inch for 15 to 30 minutes. It is done by controlling the steam in the valve. After 30 minutes, switch off the current and let the autoclave cool down, and thus the pressure comes down to zero mark. Then the autoclave is cooled down, the lid is opened and taken out the materials. What are the uses of autoclave means? It can be used to sterilize non-carbohydrate media, broths, agar media, contaminated media, aprons, your rubber tubings, rubber gloves, etc. This type of sterilization is also used in the commercial canning of fruits and vegetables, and also in order to manufacture sterilized milk. What are the advantages? It is very effective way of sterilization. It is quicker than hot air oven. What are the disadvantages? Drenching and wetting or articles may occur. Wetting of articles may occur. The trapped air may reduce the efficacy. It takes long time to cool down. So this is all about autoclave. This is the picture showing the construction of autoclave. You can see water at the bottom and heating elements at the bottom, perforated resting plate, and the perforated grid. In the lid you can see thermometer, safety valve, the pressure gauge, air removal valve, pressure control valve, the screw, the lid. At the bottom you can see drain valve. Next we have hot air oven. This comes under dry heat method of sterilization. This is a dry air type sterilizer with 3 walls and 2 air spaces. The outer walls are made up of thick asbestos to reduce the radiation of heat. The hot air sterilizer is operated electrically. In this case, the heater coil is either be placed at the bottom of the oven or in the side walls. A convection current travels a complete circuit through the wall space and interior of the oven. The temperature inside the oven is controlled by thermostat. What is the principle behind hot air sterilizer? It is operated at a temperature of 160 to 180 degrees centigrade for a period of one and a half hour, that is 90 minutes. If the temperature goes above 180 degrees centigrade, there is a danger of cotton being charred. The hot air sterilizer is used for sterilizing all kinds of laboratory glassware such as test tubes, petri dishes, pipettes, flasks, bottles, etc. Other materials which will not be burnt at high temperature may also be sterilized in hot air sterilizer. Petri dishes may also be put in metal cans or wrapped with paper and placed inside the sterilizer. What are the precautions you should take while using hot air oven? It is necessary to check the proper temperature at which the materials are sterilized. You have to make sure that under no circumstances should the hot air oven be used to sterilize culture media. As the liquids will boil to dryness, there should be temperature controlling device for maintaining the temperature required for sterilization. Hot air sterilizer is used for sterilizing laboratory glasswares. What are the advantages? It is an effective method of sterilization of heat stable articles such as test tubes, petri dishes, pipettes, flasks, I told you earlier. The articles remain dry after sterilization. This is the only method of sterilizing oils and powders. Disadvantages include cotton, wool, and paper may get slightly charred. Since air is poor conductor of heat, hot air has poor penetration. Glasses may become smoky. It takes longer time compared to autoclave. This is the picture of hot air oven used in the laboratory. This is about the construction of hot air oven. You can see exhaust at the top, airflow inside, and there is a space to keep all your materials to be sterilized. Motor at the bottom, turbo blower above that. Next is laminar airflow. Laminar airflow is an equipment having an air blower in the rear side of the chamber which can produce airflow with uniform velocity along parallel flow lines. There is a special filter system, that is high efficiency particulate air filters. High efficiency particulate air filters, we say HEPA filters, which can remove particles as small as 0.3 micrometer. In front of the blower, there is also peculiar mechanism from which the air blown from the blower produces uniform air velocity along parallel flow lines. Here you can see air purification system, control system that will be provided with switches to control the functions. Inside the chamber you can see lamp, vertical airflow, power supply socket, HEPA filters, and a working table. This is the picture of laminar airflow hood used in the laboratory. We have horizontal and vertical type of laminar chambers. What is the principle behind laminar airflow chamber means? It can produce dust-free air current with uniform velocity along parallel flow lines which help in transferring the culture media bacteria free. Air is passed through these special filters into the enclosure and the filters does not allow any kind of microbes to enter into the system. Due to uniform velocity and parallel flow of air current, we can perform pouring, plating, slanting, streaking without any kind of contamination. What are the precautions we should take? We should put off our shoes before entering to operate the apparatus. We should sterilize our hands with alcohol or can wash your hands with soap, and we should not talk inside the chamber while doing experiments. Otherwise, there will be a chance of contamination with certain bacteria or microorganisms through air of our mouth. Procedure is dust particles are removed from the surface of the laminar airflow with the help of smooth cloth using alcohol. We have to wipe the surface and clean it. The UV light should be switched on for 30 minutes before performing the experiment, and the front covering glass of laminar flow is opened and kept properly. The air blower is set at the desired degree so that the air inside the chamber is to be expelled because the air which is already inside the chamber may be contaminated. One should sit properly in front of the chamber and wash the hands and stage of the chamber again with alcohol to reduce contamination. All the experiments, that is pouring, plating, streaking, etc., are to be done within the flame zone of the spirit lamp. Near the flame, you should do all the experiments. The required materials are to be placed side by side on the stage of laminar flow so that it will be easy for you to perform the experiments. Within the chamber of laminar airflow, we can transfer any media for culturing bacteria or fungi or any microbe without any contamination. The parallel and smooth airflow blown out from inside the chamber of the laminar flow is dust free. Next, we have filtration. Many of the biological fluids or gases that need to be sterilized cannot be done by the application of heat. Their sterilization is achieved by filtration method. Here you can see the SITS filter. This filter consists of 2 to 6 mm compressed asbestos fiber filter sheet. A variety of filter sheets containing different port sizes are available in discs or squares, ready for use and work satisfactorily only for a few hours. The medium to be filtered is poured into the funnel-like structure and drawn through filter sheet by vacuum. When the filtration is complete, the filter sheet is discarded and the filtrate is obtained. A modified SITS filter in which vacuum drawn filtrate technique has been replaced by centrifugal technique is also used nowadays, where the filter is mounted on a centrifuge which forces the filtrate into the tube. SITS filter consists of two parts, perforated plate and asbestos pad. They are joined together with nuts. A valve is present on the upper part through which vacuum is applied. The asbestos pads may yield alkali and can cause precipitation of alkaloids. It may shed fibers into the filtrate and absorb drug from the solution. Next we have membrane filter or molecular filter we say. It's a new type of filter. It has been developed in recent years. Unlike bacteriological filters which retain only bacteria, membrane filter retains all forms of microorganisms, whatever their size may be. In the picture you can see the membrane filter apparatus. The sample to be sterilized is poured inside the funnel Under that you have locking ring, membrane filter. There is a forceps to handle the filter. Under that stainless base, rubber stopper and filter flask. Vacuum pump is connected to the filter flask. These filters are made up of biologically inert cellulose esters and are prepared as circular membranes of about 150 micrometer diameter, consisting of millions of pores of an uniform and specifically predetermined size. Membrane filters were originally manufactured by the Millipore Filter Corporation from USA, and they are also known as millipore or ultra filters. At the time of filtration, membrane filters of various porosity are used on the principle of graded filtration. And finally, fluid free of all organisms larger than 10 micrometer is obtained in the membrane filter. This is the picture of membrane filter apparatus used in the laboratory. Next method is radiation method of sterilization. Two types of radiation are used, ionizing and non-ionizing. Non-ionizing rays are low energy rays with poor penetrative power, while ionizing rays are high energy rays with good penetrative power. Since radiation doesn't generate heat, it is termed cold sterilization also. Non-ionizing rays are the rays of wavelength longer than the visible light are non-ionizing. Microbicidal wavelength of UV rays lie in the range of 200 to 280 nanometer, with 260 nanometer being most effective. UV rays are generated using a high pressure mercury vapor lamp. It is at this wavelength that the absorption by the microorganisms is at its maximum, which results in the germicidal effect. UV rays induce formation of thymine-thymine dimers, which ultimately inhibits DNA replication. UV rays readily induces mutations in cells irradiated with a non-lethal dose. Microorganisms such as bacteria, viruses, yeast, etc., that are exposed to the effective UV radiation are inactivated within seconds. UV rays don't kill Since UV rays don't kill spores, they are considered to be of use in surface disinfection. UV rays are employed to disinfect hospital wards, operation theaters, virus laboratories, corridors, etc. Disadvantages of using UV rays are they have low penetrative power, limited life of the UV bulb. Some bacteria have DNA repair enzymes that can overcome damage caused by UV rays. Organic matter and dust prevents its reach. Rays are harmful to skin and eyes also. It doesn't penetrate glass, paper or plastic. Next we have ionizing rays. Ionizing rays are of two types, particulate and electromagnetic rays. Electron beams are particulate in nature, while gamma rays are electromagnetic in nature. High speed electrons are produced by a linear accelerator from a heated cathode. Electromagnetic rays such as gamma rays emerge from nuclear disintegration of certain radioactive isotopes such as cobalt 60. They have more penetrative power than electron beam but require longer time of exposure. These high energy radiations damage the nucleic acid of the microorganisms. A dosage of 2.5 megarads kills all bacteria, fungi, viruses, and spores. It is used commercially to sterilize disposable petri dishes, plastic syringes, antibiotics, vitamins, hormones, glasswares, and fabrics. Disadvantages include they can't be switched off, glasswares tend to become brownish, gamma irradiation impairs the flavor of certain foods, loss of tensile strength in fabric. Bacillus pumilus is used to evaluate sterilization process. Chemical methods. Commonly used chemical methods is by using of alcohol. It is a frequently used um chemical. Ethyl alcohol and isopropyl alcohol are the most used. The concentration must be around 60 to 90%. It is a toxic and inflammable. Methyl alcohol is toxic and inflammable. What is the mode of action of alcohols? They dehydrate cells, disrupt membranes, and cause coagulation of proteins. Ethyl alcohol, isopropyl alcohol, and methyl alcohol comes under this category. Application involves 70% aqueous solution is more effective at killing microbes than absolute alcohols. Ethyl alcohol is used as antiseptic on skin. Isopropyl alcohol is preferred to ethanol. It can also be used to disinfect surfaces. It is used to disinfect clinical thermometers. Methyl alcohol kills fungal spores, hence is useful in disinfecting inoculation hoods. Disadvantages or they are skin irritants. They are volatile, so that they evaporates rapidly. They are inflammable. Next we have halogens. Iodine and chlorines are uh, mostly used. What is the mode of action? They are oxidizing agents and cause damage by oxidation of essential sulfur groups of enzymes. Chlorine reacts with water to form hypochlorous acid, which is microbicidal. Applications. Tincture of iodine is an antiseptic, that is 2% iodine in 70% alcohol. Iodine can be combined with neutral carrier polymers such as polyvinyl pyrrolidone to prepare iodophores such as povidone iodine. Iodophores permit slow release and reduce the irritation of the antiseptic. For hand washing, iodophores are diluted in 50% alcohol. 10% povidone iodine is used undiluted in pre and post operative skin disinfection. Chlorine gas is used to bleach water. Household bleach can be used to disinfect floors. Household bleach used in a stock dilution of 1 is to 10. In higher concentration, chlorine is used to disinfect your swimming pools. 0.5% sodium hypochlorite is used in serology and virology. Mercury chloride is used as a disinfectant. Disadvantages are they are rapidly inactivated in the presence of organic matter. Iodine is, iodine is corrosive and staining. Bleach solution is corrosive and will corrode stainless steel surfaces. Next we have gaseous agents. Under that we have ethylene oxide. Mode of action of ethylene oxide. It is an alkylating agent. It acts by alkylating sulfhydryl amino, carboxyl and hydroxyl groups. What are the properties of ethylene oxide? Means it is a cyclic molecule which is a colorless liquid at room temperature. It has a sweet odor, readily polymerizes and is inflammable. Application. It is a highly effective chemisterilant capable of killing spores rapidly. Since it is highly flammable, it is usually combined with carbon dioxide 10% or dichloromethane. It requires presence of humidity. It has good penetration and is well absorbed by porous material. It is used to sterilize heat labile articles such as bedding, textiles, rubber, plastic syringes, disposable petri dishes, complex apparatus like heart lung machine, respiratory and dental equipments. Efficiency testing is done using Bacillus subtilis or Bacillus niger. Disadvantages include it is highly toxic, irritating to eyes, skin, and highly flammable. It is mutagenic and carcinogenic. Next, we have formaldehyde gas. This is another low temperature method for sterilizing heat sensitive items. This is widely employed for fumigation of OT and other rooms. Formaldehyde is produced by adding 150 gram of KMnO4 to 80 ml of formalin for every 100 cu of room volume, that is cubic feet of room volume. After closing the windows and other outlets, after fumigation, the doors should be sealed and left unopened for 48 hours. Formaldehyde sterilization is used where sterilization by steam or high temperature is not possible. Typical equipment suitable for low temperature steam formaldehyde processing are rigid or flexible endoscopes, all heat sensitive instruments for advanced eye surgery like cryo instruments, plastic materials such as syringes, coils, or tubing. It is considered even more dangerous than ethylene oxide and is therefore less commonly used for sterilization. It is a colorless gas but has a pungent odor. At concentration of above zero point 0.1 ppm, formaldehyde can irritate the eyes and mucous membranes, resulting in watery eyes, and at higher concentration, it causes severe damage. Formaldehyde inhaled at this concentration may cause headaches, burning sensations in the throat, and difficulty in breathing. Advantages of formaldehyde steam sterilization. It is very reactive molecule with a small difference in effectiveness between spores and cells. Faster cycle time compared to ethylene oxide. Uh, Cost per cycle is lower than ethylene oxide. After sterilization, most loads are available for immediate use. It acts as a mutagenic agent reacting with carbonyl, thiol, and hydroxyl groups. Disadvantages of formaldehyde gas sterilizations are the vapor is extremely irritating to the eyes, weak penetrating compared to EO, that is ethylene oxide, operates on high temperature than ethylene oxide. Formaldehyde residue can remain on the sterilized goods if the rinsing phase is not 100% efficient. This can be harmful for the patients. Formaldehyde gas sterilization method is not approved by FDA and only recognized in some countries. This is about sterilization techniques. And lastly, we have biological method of sterilization.